Let's take a look at how to solve radical equations. First, consider a couple of questions. An equation in which the variable occurs in the square root, cube root, or any higher root, such as the square root of x plus 3 equals 5, is called a radical equation. So our equations will look like this one. A second question to ponder is this. Solutions of a squared equation that are not solutions of the original are called extraneous. In this process, it will be necessary to check all solutions. Some solutions that appear to be proper, when you go back in and check them in the original equation, they do not check. So in this type of problem, be sure to check all solutions. How do you go about doing this? Well, first, you will isolate the radical term on one side of the equation. Then second, you will raise each side to a power equal to the index of the radical. Now, we're just going to be dealing with square roots. So when we're working this, we're just going to raise that to an exponent of 2. We'll square both sides. Then, like I said, you need to solve the remaining equation and check your results. Here's an example. I start off by squaring both sides of this equation to eliminate that radical symbol. That will simply leave 2x plus 17 and x plus 7 times itself. If you notice, it is necessary for me to work out the FOIL method here. When I work out the FOIL method, I have x squared plus 7x plus 7x plus 49. Now I'm going to move all the terms to one side of the equation. So I'm going to move these two terms over to the right. I have x squared plus 7x plus 7x plus 49 minus 2x minus 17. As you probably recognized, I definitely have like terms I could combine. The 7x and 7x along with the negative 2x. When I combine those like terms, that's 14 minus 2, which is 12x. Then I also have the 49 minus the 17. When I combine those two numbers, I will have 32. Now, this is a type 1 trinomial that will factor. So I have x times x is x squared. 8 times 4 would give me 32, and it also adds to be 12 in the middle. So what I need to do is solve each of these factors. X plus 8 equals 0, and x plus 4 equals 0. When I subtract the 8, I get a negative 8 answer. When I subtract the 4, I get a negative 4 answer. But I must check these to make sure they're proper. When I go in to check the negative 8, I have square root of 2 times negative 8 plus 17. And that's equal to negative 8 plus 7. Well, this is negative 16 plus 17, so that's the square root of 1, which is 1. But negative 8 plus 7 is a negative 1. Do you see how these are not equal? If those are not equal, then negative 8 is extraneous. Do not include that answer. Now I'll check the negative 4. I go back into the original equation again. This time I have 2 times negative 4 plus 17 square root, and that would be negative 4 plus 7. Well, this is negative 8 plus 17, which is 9. The square root of 9 is just going to give me 3. Now negative 4 plus 7, when I combine those, that's also 3, which is true. The only true answer is the negative 4. Now here is another example that's a bit more involved because you have two radicals. When you have two radicals, move one radical to the other side. So I'm simply going to move over the square root of x plus 12. That will leave me the negative radical x minus 15 and 3 minus square root of x plus 12. Now I will square both sides. That will leave me a positive x minus 15 on one side, but on the other side I'm left with an interesting expression. It looks interesting, and I must use the FOIL method to solve this. So 3 times 3 is 9. Then I have negative 3 radical x plus 12, negative 3 radical x plus 12, and then radical times radical, that's going to be a negative of the x plus 12. Just like that. I put that in parentheses because I want to make sure the signs turn out correctly. Now let me clean this up a bit. I have 9 minus 6 square root x plus 12 because I can combine these like terms. This subtraction sign, negative times negative would have been positive anyway in the previous step. Negative times negative is positive. So I don't have to worry about the subtraction sign, but I do have a positive x and a positive 12. Now this x minus 15 that's on the left, I want to move those over so that I get this equal to 0. Whew, this is a lot. I have 9 minus 6 with the radical. Then I already had an x and a 12. Now I have a negative x and a positive 15 because I'm moving those terms from the left. Let's combine like terms. X minus x cancels out. 9 plus 12 is 21. 21 plus 15 is going to give me 36. I now have 36 minus 6 radical x plus 12. And remember, that's equal to 0. Let me go ahead and get a little more paper here. 36 minus 6 radical x plus 12 is equal to 0. All right, we're almost done. I'm going to go ahead and move the 36 back over and use the process of squaring both sides again. If I move that 36 over, and then I could divide by the negative 6 just to make that a little cleaner looking. 36 divided by 6 is 6. Then I could square both sides, and I get 36 equals x plus 12. Hang on. Subtract the 12. X is equal to 24. At least that's what it looks like. Remember, I need to go back into the original equation now and check that.